Today's curiosity is assisted by Void Stout from Full Geek Brew Lab in Winnipeg. They describe it as having roasty, smoky notes of chocolate and a full-bodied great mouthfeel. I've had this one before, and if I remember correctly, you definitely can get those smoky notes of chocolate. Yep, I like that one. So today I'm going to be taking a closer look at this knockoff battery for Ryobi and charger. Got this off AliExpress, and it claims to be compatible with Ryobi tools, and my quick test during the mailbag showed that it would indeed power my drill and that it charges, and it is a much higher current rating anyway than any of the batteries that I do have. This is one of my batteries, which claims to be, where is it here? This one's 24 watt hours, and this cheap knockoff is 108 watt hours, allegedly. And the cheap knockoff is definitely heavier. I'm going to expect it will have two layers of 18650 stacked up in there, whereas this one only has one. And I don't even have to take it apart to show those two. You can see the end of them in there. This one has seen a lot of years. It spent about 5 years in my work truck, summer, winter, didn't get taken into buildings unless I was using it. So it froze, it thawed, it boiled, whatever. And this one actually also fell off the roof of the truck at highway speeds, but it still works all these years later. So if I get even half of that lifespan out of these, because this one's going to be a lot cheaper, I think I will be doing okay. So let's just take a look inside this thing before we get any further. During the mailbag, I tossed it into the charger, and I could see that it was charging, and it did come with some pre-charge on it from the factory. So that's all reasonable stuff. I haven't got it fully charged right now. I suppose I could have, but I just chose not to. I'm going to take it apart and see what's going on inside it first. I may actually take that other one apart too, the official battery, and compare it. There are going to be some differences, of course, because this one's got twice as much current handling capability, but the basics should be very similar. Do I have to take that one out of the top of the tower as well? Okay, fine, be like that. There. Now will the top come off? Sure, there we go. So looking down into here, we have the positive and negative power. We have a temperature connection and another temperature connection there to report back to either the tool or the charger as necessary at any given time. And we have the battery sets all tagged onto the board here. The voltage at every given intermediate point shown. That's nice. And the push button for the state of charge indicator, which lights up 3 out of 4 LEDs because, again, this thing is not fully charged. And then we have what looks like a set of 4 MOSFETs in parallel. So those will be the safety disconnects if this thing goes over current or over temperature. In series with the negative end of the battery, we also have a couple of really, high current but low resistance resistors in parallel, which we're doing some current sensing. So those two are clearly in parallel. So the current voltage drop across those is going to be negligible, but still enough for a sensitive op-amp, presumably, to boost up to the control circuitry. Also, not a lot of voltage loss from the tool itself. Can we see what these MOSFETs are? TM028N03L2. Let's see if we can find that. Those appear to be N-channel MOSFETs that are capable of max 105 amps, but the package itself is limited to 60 amps. Still, with 4 of them in parallel, that should be more than you'd need for your average tool. But beyond those obvious things, we have this 16-pin chip, which has had the numbers scrubbed off it. Boo hiss, boo hiss. And we have this 8-pin chip down here, which is equally anonymous. One transistor there, and the rest of it is a smattering of diodes, capacitors, resistors, and there's a couple of other small transistors in here, but basically what's going on is going to be happening inside those two chips, which is not all that informative, but I guess it's also not all that surprising. Let's lift this control board off and take the batteries with it, being paranoid and aware that there is a ridiculous amount of current available here. If we get any bits of metal in the wrong spot, it could do some serious fire damage to the general surroundings. There we go. So we have 2, 4, 6, 8, 10 18650s. They are parallel pairs and then set up in series. So we have the most positive end of the pack there. Those two are in parallel. Then we come over here. There's the negative end of that one tied to the positive end of the next one, and a balance connection, and it goes across and across and across and all the way across. And there is the most, that's the most positive, that's the most negative end. And that's where the current sensing and the protection transistors are. Okay, let's see if we can find out what these 18650s are or claim to be. The part number shown on the cells is YG18650 OT10C. So 18650 is the physical dimensions of the battery. That's fairly industry standard. But that YG and that should, in theory, give us some answers. And a quick searching later finds that description is being sold in various places as a 2000 milliamp hour or 20 amp cell. So 2000 milliamp hour, aka 2 amp hour, in each cell, if we trust that that's accurate. So one series string will be 2 amp hour, and the second series string that's in parallel with it will be another 2 amp hour. 2 plus 2 does not add up to 6, which I guess isn't that surprising given the source, but hopefully it's at least more than what this guy is still capable of. And again, this thing is ancient and it's been abused for its entire life, so hopefully that will do the job. And I mean, as I said, it's got lots of weight in it, so they're probably not completely fake cells. Let's put him back together. And where did those little screws go? And then once that's together, actually, before we do that, let's take this one apart. We'll keep all the screws separate so that we know what's what. And yeah, let's just take this one apart. Oh, that's interesting. It uses the same size Torx bits, but it uses the security version. Let me just dig into my screwdriver collection for a moment here. There we go. A T10 security. Okay, well, I guess that's one higher quality thing, and that also means I'm not going to get the screws confused when I put these guys back together. So hopefully this should come apart a little bit easier because it's been, beaten up. And there we go. So this one, being a lower current battery, only has the single string of cells, and we'll get into their part number in a minute. There's a little thermistor down there going on to the end of this one. I didn't see on this one where the thermistors actually are. Oh, I can sort of see it in between here. I don't know whether you can see it, but there's the leads of the thermistor dropping down there off the board in between the cells. So both actually have thermal protection going on, which is nice. This one again has the thermistor or the temperature sensor connections there and there, and positive and negative there and there. This one's got a little bit of dielectric grease on it. Not sure whether that's rubbed off from the tool or whether that was always on the battery, but this guy back here does not have that. The actual Ryobi has a couple of MOSFETs on it, and because it's half the capacity or half the stated capacity of that cheap one, then that sort of makes sense. These ones are, and there's the part number, IRF 14042, which are again, as expected, high power MOSFETs. In this case, capable of 200 amps each, and they're sitting there in parallel. So that is way farther above the other one. But still, are you going to be drawing 400 amps out of a tool battery? I would hope not, but this one is more likely to survive it than the other one. That's cool. And again, we have all the midpoint connections up to the board for balancing. So that is all completely legit, as expected. We have an electrolytic capacitor as part of its power supply for its internal chips. There is one chip down there, which I can't read. And then there's one larger chip down there. And it looks like it's got some markings, but the conformal coating is kind of obscuring them. And it's just going to be a purpose-built chip for this function anyway. Some sort of a microcontroller probably with some special stuff on it. So I'm not all that concerned about looking it up. But the fact that this board does have conformal coating on it is interesting, because this one, as far as I can tell, absolutely does not. So, I mean, that's part of the price cut, isn't it? Sure, you sort of expect that. So, interesting thing on this Ryobi board, there is a couple of header positions here which are not marked, but I'm assuming that they are for being able to talk to that main chip in there. There's also another header that's unpopulated. It's marked SW1, so some sort of a switch for something or other. Actually, maybe some of those are for a voltage monitor or state of charge monitor, which this one doesn't have, surprisingly. It is a much older battery. They may have added that later. It came with a budget kit, because this is me. I'm going to buy a budget kit. You already knew that. Anyway, yeah, that does look like a little bit higher quality board, better put together. But this guy back here is more impressive than I was expecting it to be for a cheap knockoff tool. So kudos there, I guess. Let's see if we can look up these batteries. Again 18650, because that is the physical form factor. LG branded. Let's see if I can find the actual data sheet. So these appear to be rated at 1300 milliamp hours when they were new, of course. Anyway, so they are rated lower than what the cells in this new battery claim to be. And there's twice as many of them in the new battery. So, okay, if that is an honest part number, and if they are legitimate cells, then this thing should last well over twice as long as the official Ryobi battery that I have been using. So that's interesting. As I said, if these are honest about what the cells really are, then that one should have significantly more capacity than this one did even when it was new. So I think while I've got this one apart, I am just going to throw some Kapton tape over the part that is exposed through the broken part of the shell, just for my own peace of mind. I mean, I've been living with it the way it is for years, and it hasn't killed anything yet, but this is an easy thing to do, so why not do it at this particular juncture? I'll just quickly toss these batteries back together so I don't have all this exposed danger hanging out on my workbench. And I will, I guess next I'll probably take this guy apart and just for completeness, just to see what's going on inside of it. Okay, that's those two back together. Let's take a closer look at this charger now. It weighs very little again compared to the real Ryobi charger, but and it's yellow or whatever color that, I think it's yellow, or is that one of those bright green colors? That looks like a fairly cheap plastic color, which you kind of expect on cheap knockoff tools, so I'm not going to worry too much about it. That is the same Torx 10 down in the bottom there. Again, non-security bits there. What do we have on the actual Ryobi one? That's the security driver. Oh, I can't get down far enough. I can't get in the hole. Oh no. I'm going to have to come up with another way of getting those out, I guess. We'll worry about that later. I'm going to guess that it is still the T10, but yeah, we'll worry about that once we've checked into the intended victim here. So there is the copper side of the circuit board. Yeah, it's just one side of copper. There's a bunch of through-hole components on this side, which we'll look at in a minute. Fairly clean. Good sized gap there for, I'm guessing, the AC side down here. Yeah, there's the AC input terminals. Okay. And then this will be the lower voltage side out here. Those will both be optoisolators. They appear to be, oh, they look like they're reporting back to different places in this low voltage circuitry. Okay, 8-pin chip there. I can't count those tiny little pins chip there, so that'll be controlling things. Is that maybe an op amp, or is it some other application specific thing? We'll take a look at that in a minute. These two big power transistors here. Yeah, fairly standard power supply-ish looking things on that side. Are there any more screws holding that down? No. Okay, that just lifts right out. Oh. That is, what is that wire going to? Oh, okay, that is connecting to the temperature sensing on the battery. And the second temperature sensing is that one there. There's your positive and negative voltages. Let's just take a look-see at this thing. Good size 400 volt, 100 microfarad capacitor. Got a transformer, diode there, transistor here. So this over here is the AC high voltage side. That transistor will be chopping up the voltage, punching it through the transformer. On this side, that diode will be doing diode things and making it back into DC. A couple of smoothing capacitors. Those are each 1,000 microfarads at 35 volts, and they are in parallel against the DC output of this thing. Oh, I misspoke before. These two optoisolators, this is the LED side, the primary side, the input side. This is the phototransistor side, the output side. And so they are reporting back to this guy, which is going to be controlling the transistor that chops up the high voltage DC into AC. It will be controlling the PWM on that to adjust the overall output voltage. Okay. Again, fairly standard power supply stuff. So here are the two pads that go up to the battery. And these two transistors are in the path to the positive, so those will disconnect it or connect the charging current depending on what probably this guy is telling them. Where is their connections here? Yeah, goes through all this stuff here and lands up over here. Okay, what are those? I'm going to guess MOSFETs, but let's take a look at their part number. This took a little bit of digging. The part number is correct. The manufacturer logo is correct. The package is not, at least as it's described there, but it's a P-channel MOSFET that's capable of 16 amps. It looks like there's two of them in parallel, so 32 amps, derate them down to 30 or less. That seems reasonable enough for a device that claims to be able to charge at up to 4 amps. Yeah, I'll buy that. So let's take a closer look at some of these components, because I'm noticing that a lot of them have markings on them. Starting with the one that is controlling the chopping transistor on the high side is a CR6842S, which is a GreenPower PWM controller, exactly what you'd expect. And there is how it is used in the circuit. There is the optoisolator coming from the other side, which is giving it feedback to tell it whether the voltage is where it needs to be or not. There's the gate driving the MOSFET, which is chopping up the voltage into the winding of the transformer. There is a sense resistor. There is an NTC thermistor, just to make sure things don't get too carried away. Sure,
Nice basic power supply stuff.
This little 8-pin chip, it's got a, what is that, 50 milliohm resistor beside it, so that will be sensing current, probably. And that is an LM358. I don't even have to look that one up. That's an op amp. And then the brains of the operation down in the corner here. Yeah, let's go and see if we can find that. That is less likely to be findable, but we'll give it a shot.
No surprise, it's a microcontroller. Of course, what else would it be? It's got 16K flash. It's got, can talk 48 megahertz to peripherals. It's got dual op amps, dual comparators, all kinds of different stuff in it. Exactly what you need. Applications such as e-cigarettes. Nope. Wireless charging. Close enough. Mobile power supplies. Sure. All sorts of stuff like that. But it does have quite a bit of functionality on it. Lots of GPIO, more than you're going to need for this. Comparators and op amps and gain amplifiers and ADCs and timers. And yeah, all the good stuff that you'd need. Oh, it's got a couple of UART ports and SPI on it. Wonder if this one's got programming headers on it, maybe?
Nah, they didn't break programming headers out. Why would they? They'll just clamp onto that and program it, or probably actually pre-program them before they even get soldered down. But it's not an unreasonable thing. Again, there's no conformal coating on it. There's a few fluxy skid marks on here from soldering down some of the through-hole components, but not too bad all in all. I guess while we've got this apart, we should look at the AC side of it and just see how well designed it is. So there is where the power comes in, and it is on a plug, so you can replace this North American cord with a European one or a UK one or any other localization. Goes here, one side goes there, one side goes there. This one is a fuse, that one is an NTC thermistor, so that's inrush protection. The fuse says it is a 3.15 amp, so that's reasonable. Then we have an MOV across the two lines, again to just clean up any excess voltage spikes. We have a class X capacitor across the two inputs in parallel right there, and then we go over here to a common mode choke. That's all very sensibly designed. That goes to a significantly large bridge rectifier, which knocks her down to DC. That capacitor smooths it. Small series resistor there, and the smooth DC goes through this transistor here to be chopped up under control, as we saw earlier, of the little 8-pin charging chip, DC power supply chip. That does all of the usual stuff. That's quite sensible, actually, quite reasonable. There is our gap. The narrowest that the gap gets is when it goes underneath the two optocouplers, and it can't get any wider than those. All the way down here, life is good. I'm not mad at that at all. I would like to, though, see what the actual Ryobi charger looks like, but unfortunately, like this one here, for instance, when you put it in there, it's way down there, and all of my driver shafts are too big to get down into that hole. Oh well, we learned what we wanted to learn about these cheap guys. They work. It's reasonable. There's a few corners cut, but nothing too bad. I don't feel bad about using this at all. The ratings on the current handling components seem to be in line with what they should be. There's good AC separation here. It's actually fused. The thermistor or temperature sensors, I guess they are thermistors, seem to be going where they should be going. Where does this one go on here? I didn't even check that. Okay, yep, that goes up into here and into the main chip, which is exactly where you'd expect it to go. Yeah, I'm not mad at this at all. I think it should be fine. I should be able to charge these batteries with the official charger. Actually, let's just try that. That is one thing that I didn't try. The battery right now is sitting at 4 out of 5 bars, and when I measured it, it was 18 point something or other. I drop it in there. You get blinky light. That was the testing, and this one is blinking saying it's charging, which is exactly what it should be doing. I'm glad it's not detecting that this is not a real battery. It's just happy with it. That is grand. So all in all, this guy is quite a reasonable little charger. I'm not concerned about that. My biggest question is whether the cells on this thing are labeled accurately or optimistically. If they are actually correct for what they're saying they are, I think that's going to be a pretty good battery. And at a good price, getting it, like I said, off just AliExpress and with a charger thrown in for good measure. Well, I hope you enjoyed that. Got some information out of it anyway. I feel informed, and I also feel much refreshed with my confidence in both this cheap battery and the cheap charger that came with it. I think I'll probably bolt that one to the wall in the garage and keep this one in the bag, in the tool bag. Oh, yeah, thanks for watching. Questions and comments down below. If you have any experience with these cheap knockoff batteries, I'd like to hear from you. I know a few people commented in the mailbag video that they were pleasantly surprised and weren't expecting much out of them. I also wasn't expecting much out of it, but yeah, I seem pleasantly surprised. If it, explodes or burns out my garage or something, I'll certainly let you know. But in the meantime, yeah, I'm pretty happy. Thanks for watching. I'll talk to you later.